All right, so this video is going to be on how to use the shortcut for graphing a quadratic function. Now, right now we're doing distance learning, and normally when I show the shortcut, we've been doing graphing quadratics for a long time, and we get used to that original method. So right now, if you don't understand how to graph a quadratic normally, all right, I want you to really make sure you focus on doing that because graphing a quadratic with a shortcut is not necessary, okay? But it is a nice quick way to do it. So the equation that we're going to use is we're going to use rise is equal to run squared times a. Now, the reason for this is what we're going to be doing is we're going to find the vertex just like normal, okay? So let's just say our vertex is there. And the way the shortcut works is we're going to be running and rising from that vertex to find our other points rather than having to plug it into the equation and the table and everything like that. So let's just say we're going to run 1, so 1 away from our vertex. This equation, when we plug in, is going to tell us how much we have to rise, okay? And when we do that, it obviously mirrors over. Then we're going to go ahead and run 2. 1, 2, and again, we plug into our formula, and it'll tell us how much to rise, okay? So the idea here is we're always going to be running 1 from our vertex, 2 from our vertex. We want to find the points that are 1 away and 2 away, and then maybe even a third 1 away if we have the room to graph another point on each side. So again, this equation is going to tell us how to plug in to that formula. So I'm going to go ahead and use the first problem from our work yesterday. So that was the equation, let's see, y equals 2x squared plus 4x minus 6. So we're going to start by finding the vertex just like before. So we're going to go ahead and, for the axis of symmetry, x is equal to negative b over 2a. So it would be a negative 4 over 2 times 2 is 4. So x equals negative 1. Okay, so we have the axis of symmetry right up here. And then we're going to go ahead and plug this back in. To find the y value of the vertex. So this is where I'm going to use function notation. So instead of y, f of x, and plug in negative 1 for x. I'm just doing minus 4 because I plugged in the negative 1. So f of negative 1 is equal to 1, negative 1 squared is 1, times 2 is 2, minus 4, negative 2, minus 6, negative 8. So we have the vertex of negative 1, negative 8. So I'm going to go ahead and make that now. Let's go ahead and erase. I'm going to leave that on there for now. Okay, so negative 1, negative 8. Negative 1, 1, 2, 3, 4, 5, 6, 7, 8. All right, so there's our vertex. So again, normally what we would do is we would make a table and we'd plug in 2 points to the left, okay, and then reflect them over to 2 points on the right. Alternatively, we're going to use this equation, like I had said, of rise equals run. I'm going to run out of room over there. I'm going to do it under here. Rise equals run squared times a. All right, so the way this works is this. We are going to be running, for the first one, 1 away. Okay, so my rise is equal to 1 squared times our a value, which is 2. Okay, so this is basically just 1 squared is 1 times 2. So when I run 1 from my vertex, I'm going to rise 1, 2. And I mirror that over, so it could be either side. Now I'm going to go ahead and try it where I run 2 away, okay, 2 to the left or 2 to the right of my vertex. My a value still stays the same. Now I'm running 2. So it'd be 2 squared, which is 4, times 2 is 8. So when I run 1, 2, I'm going to rise 1, 2, 3, 4, 5, 6, 7, 8. And take note that if my a value was negative, okay, that would be a reflection, so we'd be rising. A negative value would be going down. Okay, so here we go ahead and graph our parabola. Oops. Not the greatest parabola. I'm going to go ahead and just show you how we don't have the room to graph another point, but let's go ahead and see if we were running 3. We plug in a 3 here, and we would rise 3 squared is 9 times 2 is 18. When we run 1, 2, 3, we are going to rise 18. Okay. Now take note, we are always resetting after each one and doing it from our vertex. It's not like we're run, rise, and then run, rise from the next point. It's always from resetting and from that vertex. All right, so that's how you use the shortcut. give it a try on a few other problems, but I would say try it the normal way first and check it against that. All right.